name's Kevin Stevenson, and I'm an associate engineer, mechanical in the key accounts group for Nordson Corporation, the Advanced Technology Solutions division. And up here on the front, you can kind of see little bits about Nordson Corporation. For those of you who are maybe taking notes or something, I've purposely sort of listed bits and snippets and other things so that if you want to quickly jot something down or type something up, you can reference something quickly. But anyway, you can find out about Nordson by going to nordson.com. And I think the presentation will be available soon, and you can click on the link. But essentially, we engineer, manufacture market differentiating products using dispensing adhesives, coatings, and sealants, and also biomaterials. Bit number 2 is therefore consumer non-durable, durable goods, and technology end markets. I've highlighted the areas in which my division is focused on. So dispensing adhesives, coatings, and sealants, along with the electronics. For the Asymtec products, surface treatment, and using precisely controlled dispensing of the material, not only for location, but also volume. Here in Carlsbad, California, we design and manufacture both software, the machine, which is the electrical, mechanical, and the valves. So going back one slide, up here in the left-hand corner, that's a sample of our valve. Center photo, that would be one of our dispensing machines. So essentially, parts would convey in from one side, and the software would control both entrance of the parts. And you can see here in the middle, there is a valve, and we dispense fluids on mostly circuit boards and other things. So most of us have TVs and cell phones and computers. So the components and things that are attached that are protected in things like the voice modules, cameras, things like that, chips on the board, the valves apply coatings or materials that will attach them to it. And essentially, bit number 5, convey it in, dispense it accurately, both placement, volume, and do it efficiently and quickly. So just some things about me and who I am. I've been an associate engineer here at Asymtec for the last 3.5 years. I've been employed here for 14.5 years, married 26 years. Today is actually my anniversary. I have a son and a daughter. My son is a junior in high school, and my daughter is a freshman. Born, raised, and live in Southern California. Some highlights for snippet 3, Eagle Scout. I have an AA in mathematics, a BS in biology, and an AS in engineering. I enjoy hiking and camping and most outdoor stuff. I'm also an avid CrossFitter, been an athlete for about 14 years, and a coach for 6.5. Serving in the community, I coach sports for my kids in the neighborhood. I'm active in my church, and I've done some outreach missions to Mexico, South Africa, and also Kenya. Experience, I've done construction, roofing, plumbing, framing, lots of other things. Teacher credential program, production chemist for working in a couple biotech companies. I've also done IT help desk and systems administration, and as a mechanical technician as well. So what am I responsible for, and what do I do at work? I work in the key accounts group. So our group specifically targets and focuses on our key customers and what they need. I monitor the machine configurations and their assembly exactly. I also test and validate for our customer specifications, the machines and all of the parts and assemblies that they want specifically on those machines in order to do what they want for their processes. So my key responsibilities for shipments are in the millions annually. The focus is to move from pilot, which is essentially existing or new products in development or new products that are being introduced, to actual production, where other people follow directions and things to manufacture our equipment. And I've actually done that for both biotech and here in manufacturing. So what do I work with? I work with BOMs, which are bill of materials. I work with OMSs, which are operational material sheets. They describe how to assemble, set up, and test all of our assemblies and equipment. It covers both software, the mechanical aspects, electrical aspects, and our valves. Specifically, this was kind of a big one, the work at number 4. So in order to do pilot to production, the interesting thing is that oftentimes with our key customers, we don't have anything that's actually released to production that's well formulated, well thought out, clear directions and things. So we actually need to manufacture and build in pilot and make sure that we can ship on time, but it's also creates a little bit of tension in being able to move things along to the production environment. So I kept asking myself, how can we make this easier on ourselves so that it's not always a lot of repeating last minute extra work and hard work for a few people just to make sure that we get things delivered, tested and delivered on time. So honestly, using the scientific method, I asked myself, how can we improve? And through observation and some testing and other things like that, managed to be the architect to double production for shipments in 2019. I was a key contributor. We were still in pilot phase and was still creating the OMSs and doing training. And the result actually of doing that exercise was in the first 6 months of 2019, we shipped almost as many units as we did for all of 2018. So that was a really large accomplishment. And for that, my task at work is to do that for the new platform for one of our key customers, to move it from pilot to production, and also to integrate more, instead of separate little islands doing this, that, and the other thing, we're trying to integrate into one nice production integration. And again, responsible for the OMSs and training. STEM at work. I didn't know it, but yes, it is at work for me. So for instance, the BOMs, the OMSs that I do at work, it really represents what I did in high school and in college in the laboratory classes. It's essentially lab experiments. And the key focus for me, both in biotech and here in manufacturing, is I basically need to write it and describe it so that someone else can actually repeat it and do what I did and get the same results. Like I said, lab experience, both biology, physics, chemistry, all of those played a role in helping me do what I do. For technology and engineering, those two items really helped me to understand the big picture and the basics, and essentially to make connections in order to solve problems. And because there's usually, even though we try and do things reliably and repeatably, there are always items that come up that things don't always work the way they're supposed to. And so again, STEM number 3, again, the scientific method really helped my goal. And actually when management asked, you know, how do we increase production and how can we meet our customer demands? I'd already been thinking and kind of experimenting with it at work by observation, looking around to understand how, what kind of connections we have with people and the systems here at work, and really honestly asking the question over and over again, how can I? So again, I utilize pretty much all of my STEM training and basics, because when things do not go as planned, whether in pilot or actually production, or they don't go as well as expected. Like I said, I'm constantly using the scientific method, and oftentimes it's interesting at different points. If you're keeping an eye out for it, you can make connections that you didn't know were there. One of the questions that was asked for being a presenter is what I do now, was that what I was aiming for in high school and college? And the answer is not exactly. So just a brief idea of how did I get here. I really didn't know what I wanted to do for my life when I was in high school. So I had questions, and I didn't have a whole lot of money. No one in my family had actually finished college. So I didn't want to spend a lot of money at a four-year to try and figure it out because I didn't have it. So I went to community college and took classes and experimented, and decided that I liked math, and I thought it would be cool to build bridges. So I had decided to become a civil engineer. In order to get to my four-year, I worked construction and continued with some classes at community college. I eventually went to Cal Poly Pomona. Like I said, engineering was my goal, but some circumstances and things came up, and that didn't work out. Pursuing a math degree, that also had some challenges, and to be quite frank, focusing on work and earning the money to go to college, that actually hurt some of my my math skills. So I was looking at having to repeat some things, and so I decided, with all of the math and science and things that I'd already had, a bachelor's in biology was the way I wanted to go. And thinking about it, you know, I really appreciated some teachers and some professors in college, actually, who were kind of instrumental in encouraging me in things. So I thought about, well, I'll just return the favor and become a math and science teacher. So once graduated, sent out the resumes as most people do. Got a lot of interviews, but no jobs. So wound up substitute teaching and starting my teaching credential program. And the teaching credential program kind of got interrupted because I was actually student teaching, or actually substitute teaching. And there were actually two teachers who had their PhDs. And I asked them why. Why PhDs? Why did you leave biotech or research? And why are you teaching high school? And they said, you know, we like what we do and we wanted to enjoy it. So I thought that was really interesting. And so when I got a phone call out of the blue for a job at a biotech company, I said, you know, what do you think? And they said, you can always come back, and that kind of work experience is really valuable. And having observed them in their classrooms and things, I really thought and saw and observed that it seemed there was a higher level of challenge and learning going on in their classrooms. So I went for it, worked in biotech, got laid off twice because with products that are in research, when you get bad news on third phase clinical trials, it's time to conserve cash, and so people get let go. So I went from one biotech company to the other. I had actually made a good impression with my boss's boss at my first job, and when he found out that layoffs were happening, he called me up and said, would you be interested in working over here? So there I went. And then after my second layoff in biotech, went back to construction, picked back up the teaching credential, was actually working on my student teaching. And again, a little something happened. Actually, not a little something, but went back to construction. So with all the things that I had been doing and had learned, managed to solve an important problem for a friend of my wife's. And he thought that was pretty interesting. So he actually offered me a job in the IT. So I started out with the help desk and then worked my way up through the beginning stages of being a systems administrator. And then from there, I started out as a temp here at a Simtech as a mechanical technician. Wasn't really my training, but again, with construction and STEM classes and things, I picked up enough to where I could actually be competent in providing some assistance. So the temp position actually worked into a permanent position. And again, I started out here as a mechanical technician, and one of the opportunities here at work was with a lot of experience and some education, you can get a promotion. So that's what I did. I went back to school. I got my AS in engineering from Palomar Community College, and 3.5 years ago, I was promoted to associate engineer. So why STEM and why not? My answer is why not? Because it does matter. STEM really has given me a framework to live and work and play. It's allowed me to transition and achieve. It's really encouraged my observation skills, and it's really allowed me to kind of check and test what really is, whatever I'm doing. What math taught me, it taught me discipline, order my steps and show my work, especially in what I do right now. That's really important. You know, if I'm working on something that hasn't really been developed, that's, you know, the engineers that design it and think about it, how it's supposed to go together, and it's not working right, well, going back and reflecting on things that I've done in the past and how we can make it work. Math also taught me to look for efficient ways and connections of what I know, and because in math, you can work the hard way and the long way, or you can put some things together and work smarter, not harder. What science taught me is to wonder. It's a big world out there, and it really is amazing how it all works together. And there are also a lot of details too, and they matter as well. For IT and technology, how computers and information systems work was a real eye-opener, and it was always really interesting to see how people interacted and used that technology. And as far as engineering goes, I'm still learning. So STEM, it's challenged me to know the basics so I could make and extend connections to bigger things or smaller things in order to get things done, whether that's work or really in life. It makes things simpler and faster and better, in my opinion. So if I could have some encouragements and lessons learned for junior high, I really think that affirming and encouraging wonder in science should be a primary focus. And also the fact that make an environment that is comfortable, and students feel the freedom to take some risks, because in a lot of ways we're discovering, and discovery is learning, and there's oftentimes no really right or wrong answer. It's just kind of answering the question, good, better, best. How little makes up the big, and how big possibilities there are for their life and their future. I think it's really important, again, show your work and your steps to solve a problem. I'm a big fan of note cards. I still have some from college, and I've encouraged my kids to do the same. In high school, the encouragement is really practice the basics and master them, because that really allows you to make things permanent. And in practicing, it helps you do it and do it well, because in a lot of ways, I think most people are really looking to stand out, and that'll help you do that. The other thing in high school is it is work. I think we all would like to have it easy all the time, but science is work, and sometimes it takes extra work. But I think I know taking the time and the extra effort in the short term reaps mid and long-term payoffs. And again, encouraging them to look for the connections within their subject, but also within other subjects. Like I repeated myself, continue to show your work or your steps to solve some problems. Like I said, it's just invaluable to me, whether in biotech, because really in biotech, the idea was you hire degreed individuals in order to develop the pilot process, which is manufacturing drugs or whatever it is in really small quantities but the opportunity is you want to manufacture that, you know, and go live. And so we're talking from microgram, milligram quantities to kilogram quantities. So when you're doing that, you're really looking to scale things up, and having things written down, being able to reflect on them, how well did it go, is an important part. And if they start when things are simpler, when things do get more complex and harder, like they will, you have some good habits to support your success. And I find it really isn't that easy to remember stuff. So point number 9, be present. I find in a lot of ways in manufacturing, sometimes in biotech, and just working with students in different areas, don't be in such a rush to finish, because you actually shortchange yourself. And practice patience. Again, not always in a rush to finish. Last slide, I believe. Life seems to be an ongoing word problem for me. It's like math. You know, what have I got? What have I been given? What is it? If I don't know what it is, then find out what it is. Like I said before, I often ask myself, how can I? How can I do it faster? How can I do it better? Is there an easier way? Is there a way to help someone else out? Because asking those how can I questions, I think it's, again, sparks the wonder, but also it sparks growth and an appreciation for learning, and actually to be a lifelong learner. The other thing is works for me, both in biotech and actually manufacturing, work seems to be sort of an unending series of lab experiments. You know, I'm always asked, can you do this? Can you do that? Customer is always asking, can your machine do this? Can your machine do that? So again, always asking the questions, how can I? Also asking the question, did I get the result that was intended? Well, yes. Was it good? Is it better? Is it best? Well, if it's no, what do I do? Do I do something different, or do I try something completely different? Well, if the answer is sort of, what kinds of things can I tweak or rework? What kinds of things can I change out or do a little different? Or did I make a mistake the first time and I just need to try it again? And again, it's what I do all the time in the pilot mode for both software, mechanical, and electrical. Point number 12, essentially what I do at work, I kind of live in an area, and it actually relates to point number 13. I call it big box or black box engineering. You know, those are the guys who are really doing the design work, who are getting the hard questions from customers. Can you do this? Can you do that? How can we do this? How can we do that? So they're designing things and creating things. And then we're asking individuals who follow directions and assemble things and put it together. So that's kind of the white sandbox. I call that production. What I really see right now as an opportunity in manufacturing industry is there really are very few people who what I call live or work in the gray, which is essentially bridging the gap between the black box and the white box. And I know enough to sort of live and play in the black sandbox, but I've worked my way up from just assembling things and installing things to where I am now. So I kind of have an appreciation or idea what goes on in the white sandbox. So like I said, gray is where I see the most potential for growth and for jobs for individuals who pursue STEM careers. And the other thing I've learned is you really won't know what connections you need until later on. So again, if you are patient and observant, then you never quite know how you will see things that come up in the connections they provide. And lastly, relationships matter, whether it's subject matter or people to people, people in your environment. Like I said, STEM really has given me a framework to do the job I do, to do it as well as I do. And that's pretty much it. Thank you for your time. You are more than welcome to contact me. I think Kim has my contact info. If you email me, just put in the letters TEP in the subject line. That way I know kind of who you are. My email flags people who contact me from external sources. So I can get to that. some people ask, do you have tours? Well, we used to, currently not right now, given the environment we're in. And as I was preparing for the presentation, Nordson has a nonprofit where we sponsor different organizations doing community service, education, and other things. And so I was thinking I'll ask our administrator for a list of the organizations, because I think there's could be some nonprofits that we are in contact with that may be available to make other connections to offer some assistance in what you do in the classroom. Thank you very much. And the questions.
Thank you so much. If we were in person, you know, we'd all clap for you. So I also really want to thank you for presenting. It's actually very, very exciting to finally have a Nordson speaker at TEP. So I guess a couple of questions that came up. You've had a lot of different STEM jobs and in a lot of different fields and areas. What would you say are like, I mean, I know you kind of covered it, but like, what are like your like 3 core skills that allowed you to really transition through a variety of career fields?
To be really honest, I think it was the scientific method. I mean, really, all the class, I love learning. I like knowing how things work. And again, the scientific method really offered me an avenue to discover, but also to say, how do I do this? And again, it took a while, but learning the basics for math, learning the basics for biology, learning the basics for technology and things, because I chose to take risks. At first, I wasn't very confident, but, you know, I wanted to be someone in my family who finished college. And again, to be honest, I worked construction and I did really good work. I could have stuck with that. But I also understood that that takes a hard toll on your body, roofing, framing, all that kind of stuff. And I saw people who were kind of more ahead than I was. So I could have invested in a truck and tools and things like that and developed my own crews to do things. But I thought, you know, I'd rather work smarter, not harder. And I think that was probably the other philosophy that just sort of came about. And I think, like I said, math lends itself to it. You know, there's a lot out there in all the subjects. And the other thing is, I really didn't make some of the connections until I was put in an adverse situation where I had to kind of ask myself, how can I? I had to figure it out. Again, the big questions were, you know, how will I handle adversity? My observation is with students and even with people in manufacturing today, some people are afraid to risk. And a lot of times people are afraid to actually work or put in the extra effort. And so anyway, there really is no substitute for hard work.
I know it. I've been yelled at a job for taking initiative before, which is the worst, right?
Yeah. Well, I won't apologize if you don't like it. I'm over it. You know, like I said, thinking about it, you know, a butterfly, how do you get a butterfly? From a caterpillar. Well, what does the caterpillar do? It goes into a cocoon, right? So the chrysalis, if you are watching it trying to struggle and get out, well, if you help it out, you're actually not doing it any favors. It only survives and becomes a butterfly and flies away because it struggles. So, and that was kind of the thing is, it took a while to adjust to taking risks and working hard.
So you mentioned like you've done tours, but you know, obviously we're in the middle of pandemic, and I feel for you in California, over in DC, because it's been, I don't know, what are we on? Like month 14, coming into month 15. I don't know. I lost track at some point.
Yeah, I'm not keeping track.
Would Nordson ever consider doing like a virtual tour?
Could be a possibility. I think there is some technology and stuff that would allow for that. And I can ask about that.
Awesome. Yeah, that'd be really interesting. And I want to ask, I know sometimes there's the processes that get like a little you know, sometimes it's trade secrets. So.
No, not really trade secrets, at least in the areas that we could probably
that you would actually show us.
Walk through. I mean, we have a standard production line. There's just lots of machinery and parts and other things, people working. So, but it is interesting how things are laid out, things are processed, things like that.
No, my dad did dairy production work, and it was always fascinating to go into the plants. Even though I didn't know what things were doing, fascinating.
I think one of the fun things that I did, we visited a Jelly Belly factory up in Northern California, and that was fascinating. You know, how hard can it be for a jelly bean? Well,
food production it's a lot of work.
Oh my gosh, you know.
You got to clean everything all the time, because otherwise people get really sick, and then the company gets sued. It's a whole thing.
Well, it was just interesting how they actually formed the forms for making the jelly beans, how they actually mixed up the stuff and baked it, how they sorted it, how they mixed it, how they bagged it. You know, I guess it's a jelly bean, but has some pretty interesting processes that go into that.
All right, awesome. We are actually out of time. If I have any more questions, I'll be in touch, but I also very much want to, we'll be in touch about, if you have other resources. I know I've been in touch with Sarah, but and then we can certainly be in touch about a virtual tour maybe. But I really want to thank you for presenting. It's really always really, really interesting to hear people who have done a variety of things in STEM and have really, you know, very clearly thought about those things.